It's my pleasure to announce my subject fellow, Maikel.
Yes.
Maikel is a MediaGenix. MediaGenix is a visual works customer for about 20 years now. They have a team of about 30 small developers, and he's going to talk to you about continuous integration.
Thank you. Thank you. Okay, so I'm Maikel Vandorpe. I'm from MediaGenix, and I'm going to talk today about continuous integration, and more specifically about how we at MediaGenix go about doing continuous integration. Just like Tim Creek last evening, we believe in scenario testing. We actually call it acceptance testing, and that's why our tests are running very, very long. So we had to figure something out so that we were able to test as much as possible every version that we are building. So that's why I will be talking first a bit about MediaGenix, who we are and so on, and then I will actually talk about the system that we built in-house to test as much as possible the versions that we built. So first about MediaGenix. What's our product, what are our customers, and a little bit of technical product information about our product. So what's MediaGenix? MediaGenix is a product company. We only have one product. It's called What's On. It's been around for 20 years. And we actually make this product for TV stations, radio stations, and video-on-demand providers. So we support the back office for those three kinds of customers. What does this actually mean? Well, take for instance a TV station. As an output of our system, you have, for instance, this paper version, but which is the schedule of what they will be transmitting. But you can also have an electronic version, or the actual playlist that will be transmitted on the air. So, but before a TV station can transmit something on the air, there's a lot of work to be done before that. So, take for instance a typical TV channel. On a typical TV channel, they have about 30 programs every day. So that's, for instance, a movie, a series, a documentary, the news. So that's 30 programs they have to plan in their schedule. But if you ever watch TV, you know they don't only transmit movies, they also transmit movie clips, promotions, where they advertise what they will be transmitting later on. They put graphics on the screen. They put running clocks on the screen saying in 30 seconds and 29 seconds the news will be coming. So if you add all that, you have about 300 items every day on every channel, but it's not finished yet. They actually also put commercials on it, of course, because they want to make money. They also put logos on it, banners, and then on a typical commercial channel, you get about 2,000 items that they transmit every day. So if you take those 2,000 items, that's not just putting it in a schedule and it's finished. No, there's a lot of work to be done for every item before you can actually transmit it. So take a typical movie. You can't go to the video store, take a DVD, put it in a DVD player, and then that's great, play and transmit it for the whole country. No, you need to buy the rights for it. You also need to get decent video material. DVD quality is not good enough. Sometimes you need to do subtitling because it's in English and you need to subtitle it in Finnish, or you want to dub it or you want to voice over it. You also need to be sure that the technical quality of your material is good enough. And so all of this has to be governed by the TV station. And that's where our product comes in. All these kinds of things are supported by our product. So if you would, for instance, take one TV program, one movie, to actually get this transmitted, you need about 3 weeks of work by one person to transmit it on the air. But of course, there's a lot of different people working on it. The rights are typically done by contract people. Technical assurance are done by technical people. subtitling is mostly sent out to a different company, and we actually make it possible to arrange all these workflows together so that they can work on it like this. So that's about our product, our customers. In America, we have then Media and Fox, but we're mainly situated in Europe still. So take, for instance, YLE, which is a Finnish public broadcaster. They have 1,200 people working on our product. Well, that's actually the TV channel, TV station that has most users working in it. But on the other hand, MTV, for instance, MTV in Europe manages 160 TV channels within our product. So that's quite a lot. Okay, that's about our product, our customers. I told you the product is called What's On, but actually, so if you have the product, every customer wants changes for themselves. So if you can actually say that we're selling, well, I didn't mention that we have over 30 customers, but we can actually say that we are selling 30 different products that are all ended on the same base product. So if for every customer, we do some modifications so that it's what they want. Okay. Well, in the company, we're 80 people. There's 26 Smalltalk software developers. There's still, even though we're doing continuous integration, there's 19 people in QA. We call them customer support analysts, and also project managers and so on, of course. A bit of technical product information about What's On. This is actually an account of last year at ASIC. Our application is actually What's On, written in Smalltalk and running on top of a relational database. So the application itself contains 1.9 million lines of code. I'm talking about the base product now, not a customer-specific thing. And we've written 15,000 classes of our own to actually manage all those workflows within our product. And there's 200,000 methods that we've written on our own. A bit about the database. For a typical customer, okay, it can change a bit, but there are around 1,000 database tables. If you would count all the rows in all those tables together, there are 40 million rows of data on average, and there's 200 people on a typical TV channel working in our product. Now, I've explained a bit about what we do and what our application looks like. And now I will get to the continuous integration part. So we have about 30 customers. Most of those customers want different things, but also sometimes the same thing. And they want it as fast as possible. We believe in small, frequent updates, like Tim Creek explained yesterday. It makes the customers happy. We have 26 developers who write Smalltalk code. And we want to have a short time to market. So we're using continuous integration to actually make sure that the quality of our product is as good as possible and that we can deliver something that's good to the customer. So about continuous integration, I will first talk about what is continuous integration, and I will explain what we actually test. So why are our tests running? Take so much time to run. I will also explain a bit what we want to achieve by this system that we build on our own. Then I will explain how our code is organized to actually be able to explain how our system is working. If I have time, I will explain a bit about the Seaside interface that we've built upon it so that we can actually govern the continuous integration system, and that reached the conclusion. Okay, so what is continuous integration? So I already explained that we believe in small frequent updates. So every developer is working on its own machine on a local image, and they release finished code very frequently, very small updates, so at least daily. And actually, if you look at our situation, we have around 70 integrations each day. So that actually also means that we're building 70 new versions each day of the product. Of course, not every version is ready for the customer, but we have 70 new versions every day. By integrating so frequently, we want to detect errors as soon as possible. So actually every integration is automatically built, so if we have a broken version, we want to detect this as soon as possible. And we also want to run all unit tests for every version that we're actually making. So that will actually also be automatically tested. So by doing all this, we want to reduce the integration problem, because we're always doing small steps and improving it a little bit and then going on to the next one. And like that, we want to be able to give a good version with new features in it as soon as possible. So what do we test? Well, the short answer is very simple: as much as possible. We do real unit tests, but the main part, the main time is actually spent on other things. We do also consistency checks. So take a customer, they have a module. We want to be sure that also the test packages for that module are in the image. If they have a certain module, it's possible that they shouldn't be having a different module. So all these checks, we also check them in the unit testing framework. And then actually the tests that take a long while, unit user interface tests, which typically calls scenario tests, but we call them acceptance tests actually. When the user, the end user at the TV station would actually do the same scenario, they will say, oh yes, this is working for me, this is what I actually wanted. I will explain it, give a small example in a bit. And we also do refactoring tests. Now if we would run all our around somewhere between 24,000 and 30,000 tests sequentially, it would take over 12 hours. It's obvious that 12 hours is way too long to actually run. So we had to figure out something to speed it up. So I'm going to explain a bit this.
What are refactoring tests?
I'm going to explain in a few slides. Yes?
Why is it you're adding new features all the time? Like, why is just as a basic question, why is your product not static? What is it that's changing in your domain or your business that you're adding features so much?
Okay, so one of the theories of developing in an agile way is to actually split a big feature into smaller sub-features. And then you have to start implementing by the smaller sub-features, and we actually already integrate those smaller sub-features.
That's not really my question.
Okay.
We've got a product called What's On, and it's basically a TV guide for satellite or online or something like that. So what kind of features are you adding, and why is it what are you adding to that you have to change things like every month you've got a new feature? Like name a feature that What's On does that you added.
Okay, a feature that we do is, for instance, you have What's On, in which you schedule the whole TV program, and then you have another system, a playout center, that's called, that actually transmits the things on the air. Now, this playout center at every customer is differently. It's supporting a different format, and then we have to actually integrate with that system in a different format. So when we have a new customer or an existing customer says, oh, we want to use a different layout center, then we say, we have to build this new feature.
And that's changing a lot? New playout centers are changing all the time? Or?
Well, for the playout centers, it's mostly for new customers, but sometimes a customer also changes, but that happens less frequently. But that's only one example. There are a gazillion examples. For instance, 3 years ago, we had 3 or 4 years ago, we only added video-on-demand scheduling, which is totally different than the regular TV channels. That's a very big feature. And if you say, I want to do this, which will take me 2 man years, then yeah, if you wait for that to build, then you're lost. So we build it gradually. Okay. So yeah, if we would run the test sequentially, it would take over 12 hours. So we can't do that. Okay, I was going to explain a bit about user interface testing. Take for instance the class person. Everybody knows what a person is. And we're editing a person in something called a person editor. So you have a lot of fields in this person editor. And now we want to write a test where we will actually make a person. We will open up the editor on that person. We will change some fields, click on the save button, and then see that there's a different person. So we're making first a person called Angelina Jolie. Then we're saying there are no persons called Bruce Willis. This test will pass because, well, Bruce Willis doesn't exist yet on our database. And then we open the editor on this person, and then you get something like this. We have just created Angelina Jolie. So, okay, this was working fine. And now we start editing the fields. We actually label every field, and then we're able to change it. So we change Angelina into Bruce, and Jolie into Willis, and then we press the save command, and then we actually get this. We get Bruce Willis. Now, at the end of the test, we will assert that now this person called Bruce Willis is actually there. This is a very simple example. The tests can be quite more complicated, but I think this gives a nice idea of what we do as a user interface test. So that's it for user interface tests. Refactoring tests. We have 30 customers. We have every year a major new version. And not every customer upgrades every year because they have their customizations and they're on that version and they're working fine with that version. But in the newest version, we sometimes have to refactor. So what happens is that the method gets thrown out of the code and typically either replaced by a different method or by a bunch of different methods. And then we actually want to write in the highest version. This method doesn't exist anymore because all the 29 different other customers are still on lower versions. And when they upgrade to that version, they will see through this test, oh, I need to change something in the code. So, for instance, this method, test that method X is deprecated, and comment there is use method Y from now on. As it says, assert there are no implementers anymore of method X, and also there should be no more references to method X. So what it does, it takes an image and actually crosses the whole code and looks for a method called method X or looks for a reference called to this method X. Does that?
Yeah, that's cool.
So that's our user interface test and refactoring test, which actually take up most of the time of those 12 hours. Now, what did we want to achieve with this continuous integration system that we built on our own? Well, we want to have a minimal time between when we actually make the new version, when the developer releases and integrates his code, and actually getting a result back from our testing system. And we also wanted to know as soon as possible when a build is broken, because you're working locally in an image, and you can actually change the load order, and I will get to that in a bit. And you can actually break the loading of an image. So we wanted to know that as soon as possible, because then you have a non-working version, and you want to avoid that, of course. And then there's actually a requirement from the customers. Whenever they have a priority 1 bug, they want to have a fixed version within a day. So if we would be running our test for 12 hours, we can't commit to this, because 12 hours is more than a working day. Priority 1 bug from a customer is typically that they aren't able to generate a playlist for what they want to transmit in a bit. That's really annoying, of course. Okay, there are some limitations. As I said before, our tests take actually way too long to run. That's because we're testing the real thing, as I call it, doing scenario tests or acceptance tests. And actually, when we start looking for a solution we didn't find anything, so we started building it ourselves. Okay, I first have to explain a bit about how our code is organized. Our code is actually on a code repository from VisualWorks Cincom. It's called Store, and Store is a relational database that contains all the code. So every code is actually on a package. So code meaning method definition, class definition, shared variables, and so on and so on. All the code is in a package. That package gets saved on Store with a version number, and then like that you can know which code is actually in your image. Several packages together form a bundle. So a bundle is just some packages together. Also a bundle has a version number, so if you load bundle X with version Y, you can actually see what's in it. And finally, several bundles together form something that we call the top bundle. Top bundle is actually a regular bundle, but for us it means something special because it contains all the code for one customer. We typically call it what's on testing XYZ, and XYZ is a reference to a customer. In the system browser, it would look like this. So on the top you have what's on testing NGX, the top bundle, which contains all the code for one customer, and then you have a bundle here, and eventually you get the packages with actually the code in it. Yes?
Sir, what's a customer? Are these different cable companies or
TV channels.
different TV channels?
Yeah,
so
like
you've got,
MTV, Fox, Netflix.
right. So each channel, each customer is a channel. Okay.
Station.
Each station is a channel, and they've got changes they need all the time. That's why you've got so many features they need to create.
Yeah.
Okay, so one customer is one channel. Station.
Yeah. Station is multiple channels, and yeah.
But you have multiple stations that you're dealing with.
Yes.
He said 35.
35.
That's what he said.
Oh, I'm sorry, I didn't catch
Around
that.
35. I lost count.
So I think what the name tag list yet would be
It grew big enough that.
I had to go back. So I didn't
Yeah,
see it,
indeed.
sorry.
very short.
Okay, so that's how it looks in the system browser. And actually, when we built a separate screen for publishing the top bundle, which contains all the customer, which actually gave us a place to put some an extra dialogue in between. So where we can say we want to schedule the test for this customer or not. And I will get back to it in a bit, why this is important. So how does our current system actually work? Well, there are four main different concepts. One is the test master, the other one is called a bundle loader. We have 4 test coordinators, and per test coordinator, we have around 16 test slaves. So this is how it looks like. Oh, wrong button. So we have store, which contains all the code in it. So when we were actually on that publishing screen, you could say schedule the test then, and then actually we would save a record in a database table, and this database table is actually governed by this test master, so it knows this version needs to be tested. This test master is actually, well, the master of everything. And the first thing it will do, it will ask the bundle loader to load a certain version in a vanilla image. And then when it's finished, it says, hey, I've loaded the version. And then this one will try to push one of these to say, hey, test this version. And this one will actually, one of these test coordinators will actually put these slaves to work. I will get more into detail in a bit. So this is the big outline. So when you have published this bundle version, we save a record in the database, actually in store, in the store database. And now the test master has a queue. Well, the queue is actually the database table, and he knows this version needs to be tested, this version needs to be tested, this version needs to be tested. So the main role of the test master is keeping track of all those versions that need to be tested. Inside that queue, we can prioritize a bit so that we can actually meet the requirement from the customer to test something, to get a version within a day. Also, you could unschedule tests. You can manipulate the queue. That's the bottom line. There's one optimization we put in because we're actually unable to test everything. We always put the latest version of a branch on top. So if you have a branch for a certain version, if developer 1 publishes and half an hour later developer 2 publishes in the same branch, we will say test the newest version first. So that's it for how we actually manage the queue. Now this test master has this queue, and it will say, oh, this one is on top of my queue. Mr. Bundle Loader, please load me this version. This bundle loader can load up to 4 versions. It's running on a separate machine so that it doesn't take up all the CPU of the test master and other services running. So after loading, the bundle loader will actually notify the test master again, hey, I finished, and it will put the image somewhere on the file server so that we can access it later on. Okay, loading our version typically takes about 15 minutes. So we actually put on a timeout for about 30 minutes. If something is taking longer than 30 minutes to load, then we say, hey, we have a broken build. Yes?
You say the bundle loader can load up to 4 versions. It
Yes,
can't load those in at the same time, can it? Or 4 versions of different packages?
No, the bundle loader is a service running somewhere,
Okay.
and it will actually fire up a vanilla image and will instruct that vanilla image to load.
Okay, so then you have multiple images, and the bundle loader is running separately on each one.
No, bundle loader is a controller that starts up the.
Yeah,
That's okay.
that's a good way to put it. Yes, thank you. So if it takes longer than 30 minutes, we know we have a broken build. Then the developer needs to have a look at it as soon as possible. Okay. So now this task master knows it has a version that can be tested because the load has been the version has been loaded from scratch. And now this task master will actually look for an available test coordinator. The test coordinator coordinates the testing of one version. So if one of those 4 are available, the test master will instruct that test coordinator to test version X, not to load version X. Then this test coordinator will do something with the test days, which will I explain later. But also these test coordinators have a timeout. They run longer, if they take longer than 75 minutes to run all the tests, we actually know there's the testing has failed for this version. Again, in favor of the priority 1 bugs, we added the possibility to nuke the tests, as we call it, to actually say, hey, stop immediately, it's time for a different version to be tested. Okay, so we're now at test coordinator, which will actually start coordinating the test of the version.
So on these tests that fail, and they make this timeout, is that just because when it fails it just hangs, it won't proceed?
So for instance, someone put a breakpoint in it, a halt in it, it's calling, yeah. So we're at the test coordinator who has accepted that we will test a certain version. And now the first thing that we will order is against his 16 states, start making a database for this version. We can do that automatically. I won't go into detail for that because that's complicated. So the first thing that all these states do is they make a local database. Because we're testing the real thing, we need to be on a database. And then when each test slave has created their database, they will notify the test coordinator, again, I've created my database, I'm ready to actually test something. And then the test coordinator will distribute test class per test class over all the 60 slaves. And it will do that in a smart order. It will actually tell the first one that's ready to test the test class that takes the longest time to run. Why have we done that? Is because if we postpone the testing of the test class that takes a long time, it might be possible that one of the slaves is at the end busy testing that long test class, while all the other 15 are actually doing nothing, sitting idle. So that's why we do it first, the longest test cases, so that that all the slaves end more or less in the same time, and that we don't have a huge peak while one of the slaves is still doing tests. Also here on the space we've put a timeout. We had to, again because of halts and breakpoints and so on. So if one of the states doesn't respond, by the time the test coordinator should be finished, it will mark all the tests that are on that that were sent to that slave as they haven't run. So it's not failure, it's not error, but they say they haven't run. That gives us an idea that we need to look there for some test failure. Okay, a small demo of apps. Wrong screen. So this is actually how a test wave is looking like when it's running several UI tests. So it opens a certain browser, it clicks on certain fields, it answers on messages, well, I of course took as an example UI testing, because if I would be showing real unit tests, you wouldn't be seeing anything on these test waves. So this is a movie of a recorded test wave testing in a certain browser.
What portion of your test cases, like what percentage are UI tests versus low-level unit tests? Is it skewed one way or the other, or do you have sort of an equal number?
No, it's we actually do a lot more acceptance testing than we do unit testing.
That makes sense.
Where actually the real unit testing is for the very difficult parts. For the regular cases, we focus mainly on acceptance testing. Okay, I think this is long enough. Okay. So after this test coordinator has distributed all the tests, gotten the result back from those test slaves, it will actually send a mail out to the developers group saying, hey, I've tested version this one. There were so many tests in the total. There were so many failures. There were so many errors, and there were actually also so many tests that hadn't run. And actually, it will also keep somewhere on the file server the stack so that we can have a look at why it actually failed there. But what we also do, and then I think this is a nice bonus, is we actually save the test results on our code repository, on store. So for every version, we have next to it, this version had been run, there were so many tests in it, there were so many failures, so many errors, and so many tests hadn't run. And that actually gives us the possibility to make integrated tools on this, and to do things, for instance, on OpenIS unit, on the failed tests of that version. And then we can also start seeing where has a certain test started failing, and for instance, who actually is to blame for that this test isn't working anymore. So if we look in these folders again, on the left you see actually several versions of several top bundles for customers, and on the right you see several versions. So for instance, for ProSieben, we have around 24,000 tests. There were 3 failures in the last build, 6 errors, everything has run, and it took a little less than 40 minutes to run. And actually we have the history here for all the past versions of that customer. Any questions so far? Okay, so all these things, well actually I forgot to mention that, but from here on, so after we put a record in the store database, from here on all the communication goes through OpenTalk messages. So these services all talk to each other using OpenTalk. But all these services run on rather anonymous servers. And that's why we actually built a seaside interface on it. It's called Vera, and it's a seaside interface so that we can actually integrate communicate with those anonymous services that are running somewhere in our server rack, and that we can actually manipulate things. So, for instance, here in green you see the actual test coordinators and what they're working on. The first one is working on YLE, this exact version. It's been published at 1547 by Chris. Actually, TVN, it's running on the second coordinator, and so on and so on. This Thunderbolt actually means that these tests were prioritized. And then we actually also have the list, the scheduled test of the versions that still need to be run. So we actually also added an estimating time of arrival so that we could know when will we get the result, get an idea of how far we are, both in time as in test classes. And these two are probably making the database, so they're not actually doing any tests yet. And so here, for instance, you see that a certain version still needs to be loaded, or is busy being loaded. You can actually get some information about a certain version and asking why is this version being published. Well, Peter fixed a bug for TFIN, wrong message number, blah, blah, blah. So you can get some information about why this build was there. Okay, so yeah, you can actually nuke the test so that you can prioritize something for a prior one bug. And the last thing about this seaside interface is you can open a view on the slaves and actually see slave 1 is testing this class and it's taking so long. The orange means the tests are running longer for this one test class than 5 minutes, and you get an overview of what all has been running. So we have a good overview, what's running where, and when will we get some tests. So to conclude, I think the goals that we posed for ourselves have been met. You know within 45 minutes if a certain build is broken, if a version isn't loadable anymore. If we are prioritizing tests, then we get the test result within an hour and not 12 hours. For the tests that we don't prioritize, it takes 4 hours on average to get the test result. And a nice bonus is that we have integrated tools with SUnit where we can ask for a certain version which tests were actually failing. There's still some improvement to do. Currently, because of some optimization, not every version gets tested because, well, if everything's busy and the queue is too long, then certain versions get skipped. But it will always be older versions that get skipped and never the newer one. We're always interested in the newest versions, of course. And I also think that we should try to even speed up the throughput of one test even further. That's it, actually, for me. Yes?
So if your test slave dies because the test goes wrong, how do you keep the slaves up? How do you respawn the images? I assume they're running on different hosts. Is that something you need to keep up manually, or you process is keeping an eye on these images and respawning them, or?
Don't think I got the question that well. So, if, for instance, a bunch of machines die or something like that?
Well, we are running a test in one of your slaves. It hits a point where the image basically just halts, or the image dies, it exits. How do you detect somehow that the slave is gone and you spawn a new one, or?
Okay, so there are several possibilities. So the test slave is testing a certain class. It's always per test class. And if it doesn't respond before the timeout, then we mark those tests as not run.
Hosts?
Oh, they're running on virtual machines and on big servers, actually.
Right.
But because we can monitor these days, there's actually several people sometimes having a look at these tests, because, well, these tests are important for us, and when they see, well, I don't have a screenshot of it, but actually the slaves get polyline would be in red, and then they would see, oh, there's something wrong here, and then they can have a look at the machine itself and fire it up again.
How do you test in the presence of a database? Presumably, every window when you make a change, it saves something to the database. If you try running that test again, that data is already there. So,
Okay, that's something I wanted to keep quiet about.
Sorry,
okay.
disregard that question.
No, I will answer it. So yes, we had some problems with that. So what you actually, when you're running 1,000 tests on the same machine, you get some legacy data from the previous 999 tests.
Yeah.
So we actually, the first thing that we did is in the, we make objects through setups, that's through something we call populators. And at the end of every time, at the end of every test, during the tear down, we actually ask those populators to kill those objects again.
Okay.
But that wasn't good enough, and now we actually have something better, but it's actually too complicated for me. Also, it actually takes more or less a snapshot of what the database was looking, and actually afterwards restore it.
Okay,
That's
fair enough.
good. Joe first?
Yeah, so I have actually two questions. One is, are you aware of a very similar setup at AMD at what's now called Global Foundries? And the second question is, when you fix a problem for, let's say, VDM, and it is shared code with VDR, how do you integrate the changes in the VDR WhatsApp?
Okay, so the first one was a question?
Yeah, are you aware of the...
No, I'm not aware of that.
So they published it at some conference, maybe 2 years ago or so. Very, very similar setup with the testing machines.
Okay, I should have a look at it.
And they have about the same amount of time to run the test, 4,000 unit tests, because they don't have UI, so it's all unit tests.
Yeah, okay. But,
And they run the fab with it, so it's full. Is the LAM guy still here? Yeah, so
I know it well.
you know about that presentation.
Oh, yeah,
sure.
yeah.
Okay, just give me some information about it afterwards. And the second question is actually about our version management control, how we do that actually. There is some overhead. If you test something for the one customer, yes, you might have to test it. Actually, also,
First, you have to do it for the other customer.
yeah, of course. So because we actually try to only ship a version to the customer with 0 failing tests. So that's a part of the answer. So we shouldn't be shipping to a customer where there are tests failing. But when there's a bug that wasn't covered by a test yet, then we need to fix that bug, for instance. And then it depends on how the versions are related actually. So we have the base product, what's on. If it's in there, then the other customer will get it automatically. If it's in one of the customizations and the other one has a very similar customization, then it's getting tricky. Yes, Alexander?
Yeah, I have a question regarding the refactoring test. Like you have shown us like the implementers and senders, but do you have like some other tests?
Do we have?
Can you test some other things such as the dependency between packages, for example?
As part of a refactoring test.
Well, you mean if you have, I only showed the simple example of it. So we can actually test if we have no implementers or no references. We're actually only in that class or everywhere except in that class, also the same for a package, things like that.
Okay, but just implementers and senders.
I think so, yes.
You cannot check like for the dependency between packages. I mean, you could say
That's actually what we do in consistency checks. We don't call it refactoring test. But we do that also, yes. Okay. No more questions, it seems. Thank you all.